Good morning, students. Today we are going to discuss chapter force, that is the first chapter of class 10th physics. So here we are going to start topic translational and rotational motion. Okay, so first let's start with the translational motion. When any object is moving along a straight path, or we can say along a body is in linear motion when any object is traveling along a straight line, when distance covered by the object is same in a given time period, right? When a force acts on a stationary rigid body which is free to move, the body starts moving in a straight path in the direction of application of force. This is called linear motion, right? This is called linear motion, and the examples are that we are pushing a ball lying on a floor, any object lying on a floor, and the body begins to move, right? So all the particles of the body will cover equal distance in equal time period. This is the example of linear motion, objects moving in a straight path or along a linear path, right? I think it's clear. Now, the next part of the topic is rotational motion, right? Now, rotational motion. Rotational motion, if a body is fixed at a point and a force is applied on the body at a suitable point. For example, consider a steering wheel of a car. It has a fixed point, and then, or any object, you can consider a wheel also, that is having a fixed axis that can be at the center also. Now, fixed at a point and a force is applied on the body. Yet you can see that this arrow that I have marked is showing the direction of application of force, and it rotates the body about the axis passing through this fixed axis. This will provide, as we are rotating this body, this will provide a turning effect to this body, right? And this is the turning effect of the force, and the motion of the body is called, which type of motion will be there? Will that move in a straight path? No. When we are applying force in this direction and the body is fixed along this point, we can mark it as O, and the body is fixed about this point and we are applying force, then the body will not move in a straight line, it will start rotating. So this is the turning effect of the force, and the motion of the body is called rotational motion, right? For example, if a wheel is fixed at a center and a force is applied tangentially. Tangentially is a main important keyword here on its rim. As I have shown in this figure, the wheel rotates about its center, right? This diagram is very important. It is given in your book also. So if you have book or whenever you will have, you can just look at this diagram, right? Similarly, when we apply a force that is applied normal to the handle of the door that you have in your room, you can just see that if there is a door and the door is given with one of the handle at the end, you can see this is the handle of the door, and we are applying force here, and this is the hinge point, right? This is the fixed point. So we are applying force at this point along this line of action, and this is fixed point, and this distance, this perpendicular distance from this line of action of force, the door begins to rotate about an axis by passing through the hinges on which the door is at rest. So these are the hinges point. Hinges point means the fixed point, the support point. So when we are applying force at this point, the door will not be in a linear motion, it will start rotating, right? So what we want to say in both the example, in the example of this one as well as this one, that when we are applying force on the body that is fixed at certain point, and we are applying force at certain perpendicular distances, then these objects are showing their rotational effect, right? So this is the main point that we have to discuss here in rotational motion. The object will start rotating. Now the main factor affecting the turning effect of the body is the first one, that is the main factor, is the first factor is the magnitude of the force applied, that how much force we are applying here in this case. So the first factor, right, affecting, you can note down also in your copy, affecting the turning effect, the turning of the body. First factor that is responsible is force, magnitude of force applied, and the second factor symbol is F, right? You can see force and the symbol is F. And the second factor that is responsible is the perpendicular distance. You can see here, this one is perpendicular distance. Can you see this one? Perpendicular distance. It is at exactly at 90 degree, right? So this is the perpendicular distance from the line of action of force. This hinge is exactly at the perpendicular distance from the line of action of force, right? So the second factor that is responsible is the perpendicular distance of the line of action of the force from the axis of rotation, right? So I'm writing in short, that is perpendicular distance, right, of the line of action of force from the axis of rotation. Okay, perpendicular distance of the line of action of the force from the axis of rotation. This is the complete expression, and whenever you will write, just write with the complete expression, okay? Always rotation, right? Indeed, the turning effect on the body, depends on the product of both the above stated factors. This product is called a final expression. This product is called the moment of force, and it's also known as torque. It's a vector quantity, thus the body rotates due to the moment of force about the fixed point. In other words, we can just make a formula also. This is the symbol for torque, and we call it moment of force also, and that is equal to the product of force that I have written here, right? This force, and this torque is defined as the product of force and this perpendicular distance that I have written. So we can just use a symbol here for this one, small r, distance, right? Force is a vector quantity, and this perpendicular distance of force from this fixed point O is also a vector quantity. So this product, finally this product of two vector quantities will give a final vector quantity, right? The turning effect on the body about an axis is due to the moment of force applied on the body. Now the question is, the second part is, how will we measure? About which I will give you few exercises also, that how can we have the measurement of these forces. So we can look at this one, that how can we measure. Measurement is the main important part of moment of force, or we can simply say measurement of torque, right? Measurement of torque, that is our main. Next topic is The moment of force is equal to the product of magnitude of force and the perpendicular distance of line of action of force that I have stated just now. Force into perpendicular distance of line of action of force, that is torque, right? For producing maximum turning effect on a body by a given force, the force is applied on the body at a point for which the perpendicular distance of the line of action of the force from the axis of rotation is maximum. In this situation, the given force provides the maximum torque to turn the body. What I am telling you is, when we are writing torque is equals to R into F, then if the distance is maximum means if this distance is maximum, if somehow we can increase the value of R, then required value of force can be minimum, right? That is why doors are always, the handle of the doors are always at the maximum distance from the hinge. This distance should be maximum, then with the very small effort we can show the turning effect, right? And this is the reason only why the spanners are of long handles, because if somehow we can increase this perpendicular distance, the required force will be very, very less, right? This is very important point to remember. And the next one is the SI unit. If there is a physical quantity, then always we have to know its SI unit, that what is the SI unit of that physical quantity. Okay, so the SI unit of force is Newton, correct? And the SI unit of distance is meter. So what is the combined SI unit of this force into distance? This distance, that is Newton meter, is the unit of this physical quantity that we are saying torque, right? This is its SI unit, and short form is Newton meter. The CGS unit of moment of force is dyne into centimeter, as we know that the CGS unit of force is dyne and the CGS unit of distance is centimeter. So the CGS unit of torque is dyne centimeter, right? So here we can have a question that derive a relation between Newton meter and dyne centimeter. So here we can derive this relation also. We can write here that, just a minute, 1 Newton meter is equals to 10 to the power 5 dyne, right? And 1 meter is equals to 100 centimeter. So we will write here into 10 to the power 2 centimeter. So this relation can be written as finally 10 to the power 7 dyne centimeter. So here we can write this value as a final relation as 1 kg F into meter is equals to 9.8 Newton meter, or the next relation is 1 gram force into centimeter is equals to 980 dyne centimeter, right? Already we know that 1 Newton is equals to, here the relation is this, we have converted 1 kgf is equals to 9.8 Newton. This one is the main conversion that I have converted. So this we have done already in class 9th, that 1 kgf is equals to 9.8 Newton and meter is written as it is, meter only. So when 1 kgf is the value, then the relation in term of Newton will be 9.8 Newton. Okay, now we can have one numerical based on this one, is this one, and the question here in this way is this one. So you see the question. A body is fixed at a point. The first example you can see, a body is fixed at a point. A force of 10 Newton is applied at a distance of 30 centimeter from the fixed point. Calculate the moment of force about the fixed point. You can see this is the first question that is given. So here we can just solve easily this question. First question of example, where the force is given 10 Newton and the perpendicular distance is given 30 centimeter. We can convert. If this is given in Newton, then we know that we have to convert distance also in the same unit, so that would be 0.3 meter. And when they are saying that calculate the moment of force about the fixed point, so the formula for force is torque is equals to force into perpendicular distance from line of action of force. So that is 10 into 0.3, that is 3, and the unit is Newton meter, that is the SI unit of torque. What is torque? The moment of force, right? Moment of force, that is also defined as torque. Now here this is 3 Newton meter, correct? So if we have to solve any question that is given here, then this is the formula with which we can solve it. For example, the next question we can see is the first question of exercise, right? The moment of force of 10 Newton about a fixed point O is 5 Newton meter, right? The first numerical of the exercise. If you have book, then you can see, you can open it. And if you don't have book, then you can see in this video and then you can solve it. Okay, so here is the question. How much is the force given? The force is 10 Newton and this is given moment of force, and we have to calculate distance. Okay, so let's write the values here in your copy. You can easily note down, right? This is the first numerical. Here the force is given, F is equals to, value is given 10 Newton, and the moment of force, we can use a symbol. Always when you solve numericals, we should always use symbol. So symbol is torque, and this tau, Greek word tau. So here this one is torque, and that is given 5 Newton meter. Another question is calculate distance. So we will use this formula, torque is equals to force into R. First we will write the formula. Torque is given 5 Newton, force is given 10 Newton, and then we have to calculate R. So this shows that, this implies that R is equals to 5 upon 10, that is 0.5 meter, right? So remember, it's a vector quantity and we can easily calculate this with the help of, once again just revise the numerical quickly. Force is given itself in the question, 10 Newton. Moment of force of 10 Newton about a fixed point O is 5 Newton meter. It is given in the question. Now the question part is calculate the distance of the point O from the line of action of force. So we have to calculate this distance R. So first I have written this formula, and then in this formula, after writing this formula, I have placed the value. Torque is 5, force is given 10, and R is R. So the value is R 5 by 10, and that is 0.5 meter. Okay, so units should be correct always. In the second question, you can see in the second question, again it is given, the second numerical, a nut is opened by wrench of length 10 centimeter, second numerical. If the least force required is 5.0 Newton, find the moment of force need to turn the nut. Right? A nut is open. So here we can see that this one is distance given, and the second one is 5 Newton, that is force that is given here. Find the moment of force. So which formula can we use here? The same one, same formula, only the expressions that are given here is different. So let's note down the values and then we can. Force is given 5 and